In this lesson, we'll talk about typecasting in Java. Typecasting is nothing but converting a value of one data type to another data type. Now take a look at this table. It's easier for us to convert a value of byte to a value of short because the range of byte is lesser than to that of the range of short. In the similar fashion, we can convert int to long. We can also convert char to int. Remember, I said character can also be represented in numericals, and the range of char surely is lesser than to that of the range of int. When it comes to converting a value of lower range data type to a higher range data type, Java does that automatically because there is no loss of information. For example, it's easier to put a 1 liter container in a 10 liter container, but not the other way. If you try to put a 10 liter container in 1 liter container, there may be loss of something. Same is the case with Java. If you try to put int value in, let's say, byte, Java won't do it by itself because there is a risk of losing data. There can be loss of magnitude in the resulting value. So Java won't do it by itself, but will ask the programmer to do so at his own risk. Let's go to our whiteboard and take a look at some theory behind it. So Java does automatically convert byte to short, short to int to long, long to float, and float to double. Here you need to note that long takes 8 bytes of memory, whereas float takes only 4 bytes of memory. All the float values can be represented in exponential notation. It can easily accommodate the maximum value that long supports. We also have char, which can be converted or typecasted to int. So if you go from left to right, we are converting the value of lower range data type to a data type of higher range. This is called widening. For example, you could convert byte to short, you could convert byte to long, you can convert char to float. And the name widening makes sense because byte takes 8 bits of memory, whereas int takes 32 bits of memory. And like I've already mentioned, you can easily insert a 1 liter container in a 10 liter container. And in the similar fashion, the 8-bit memory is actually widened to a 32-bit memory. So essentially we have widened the space. But whereas when you try to convert int to byte, you're trying to convert a value which is in a 32-bit container to 8 bits. This mechanism is called narrowing, and the arrow goes from right to left. So if you try to convert double to int, it's narrowing, long to short, it's narrowing, etc. In case of narrowing, Java does not do it on its own. It's up to developer because there can be loss of data. When Java tries to convert a 32-bit value to an 8-bit value, obviously it cannot accommodate the entire numerical. Now let's take a look at the syntax of typecasting. A quick question: what are we doing here? Are we doing widening or narrowing? We're doing widening. We're trying to convert a value of type byte to integer. This is called widening, and doing so does not yield any loss of information. Hence Java does it on its own. So it does implicit casting. It will convert this byte to data type int, as there is no loss of magnitude or there is no loss of data. But when we try to do the other way, for example, int I equals 1000, byte b equals I, compiler will complain the programmer because Java cannot convert an int value to byte without the loss of data. So the way we tell compiler that it's at my own risk, I don't care if there is loss of data or loss of information, I still want this to be done. I still want this to be a valid statement. So to tell compiler, you just have to say byte here, your destination data type, within the brackets. Now compiler will successfully compile this program and even run this program, but the result would be something unexpected. Let's go to our workbench and take a look at a quick example. So here we have a value as 2000, which is of type int, and we're trying to convert into byte, and we explicitly typecasted it to byte. Now let's try to run the program. And then let's run it. So the value is pretty unexpected and is completely useless. So let's see what has happened behind the scenes. The binary representation of the numerical 2000 is this. And since we said int a equals 2000, this entire thing is stored in 32 bits of memory. And when we say byte b equals 8, it's going to create 8 bits of memory, and somehow Java needs to manage to put this number 2000 in 8 bits. It will try its best. So Java does some sort of calculation. It will straight away ignore all the 24 bits and would consider only 8 bits, which is, and then it checks if the most significant bit is 1 or 0. If it is 0, it will straight away print the decimal number of this binary representation, and since it is 1, it will go ahead and try to do the ones complement of this binary number. So ones complement is nothing but the negation of this number. So it's just replacing ones with zeros and zeros with ones. And now the decimal value that you get is 47. It will add plus 1 to it, and we get the value 48. And in Java, all the integer types are signed. So since we have 1 here, which means negative sign, minus, it will treat this number as a negative number, and hence we got the output as 48. Throughout my career of decade and a half years of experience in using Java, I have never ever used narrowing for primitive data types. I don't even think of a scenario where you would need a narrowing for primitive data types. You'll have to check with the designers of the Java. But I did use widening a lot of times. Well, now going back a little bit, you might be wondering why char cannot be converted into short, even though they take same bytes of memory. That's because char is unsigned, but whereas short is signed. So out of 2 bytes, 1 bit will be allocated to decide the sign here, whether it's minus or plus. But whereas for char, it starts with 0 to 65,536, all are positive integers. Okay, now let's take a look at widening and narrowing examples. We have a pretty simple program here. We're converting byte to int. So byte b equals 10, int I equals b. Java implicitly convert this b to type of int because we're doing widening here and there is no loss of information, and Java gladly does the conversion by itself. Same is the case with long to float. We have a long value here, we're trying to convert into float, and this is the maximum long value that long can hold. We're also converting char to double. So the Unicode number of letter capital A is 65. So what we're going to store in double D is 65.0. Let's try to run this program. Cool, we got the expected output. Now let's take a look at example of narrowing. So we're trying to convert integer data type value to a byte. Int I equals 2000, byte b equals I. And we're printing the value of b. So would this yield a compilation error or not? It does. Because there is loss of information, we need to explicitly say that I want to convert this to byte. Now this will, we've actually already taken a look at this example, so I'm not going to waste your time running it again. Not to confuse you, but Java does do narrowing implicitly in case there is no loss of data. For example, take a look at these statements. So byte b1 equals 10. By default, Java treats any integer value as of type int. So Java converted this int data type to byte b1 gladly because the value 10 comes in the range of byte and it's not resulting in any loss of information. Let's save the program. Let's get rid of this code in here. Let's save the program and try to run it. Not to confuse you further, but let's take a look at a few more statements. Now what we're doing here is essentially the same thing. The only difference is we have explicitly initialized the variable a with value 10. Now if you run this program, do you see errors? Yes or no? The answer is yes, we do, because we explicitly stated that the value a is int, so it's our responsibility as a programmer to explicitly cast this a to type byte. First, let's try to run without typecasting it and see what happens. Compile the program. Oops, we have already seen the error. So incompatible types, possible lossy conversation. If you convert int to byte, there can be loss of data. That's what it's complaining. So I would say it's at my own risk. I wanna take care of this, so I'd say it's byte. Save the file. Compile the program. Run the program. Good. The result is expected.